Hopefully that's working. We'll see. Last stream was a shit show. Um, so I'm probably gonna make this stream short just to make sure everything's working. Let me see if it's loaded up though. You know what? It's not a big deal. It's really not a big deal. I did forget one thing that I should add. What I should. Whatever. Fuck a Pomodoro. I'll do that next time. Pretty much. God damn, that's bright. Please, please, please. Better. Oh, nice. Okay. So I'm for this test stream. I'm just gonna go over what I was trying to talk about in my last stream, and pretty much what I'm gonna start doing is I want to get back into the habit of doing a data structures and algorithm question every day. And so right now I'm trying to the school semester just started, and so I'm trying to balance work, school, and then all these side goals that I'm trying to do, like this neat code stuff. So um we're back on streaming to keep myself accountable. I'm trying to wake up earlier so I can get this stuff out of the way, so when I actually have to do schoolwork and classes and working in the way, I won't be stressed about not having this done. So that's why I'm starting the streams early. It's about 5:20 a.m. where I am right now. And yeah, with these specific data structures streams, I'm is honestly not going to be intended for teaching anything. So if y'all want to learn data structures, don't go to this stream. is better off. There's a lot of better resources. I really am just using this so that I can really set this information in my head. Like you learn best by teaching, right? So this is me teaching, and hopefully it helps me remember this stuff. This is my third time teaching, so I feel a little bit confident about this question. But pretty much, this question is called subsets. It's a medium level question, and it asks, given an array of nums of unique integers, return all possible subsets of nums, right? The solution set must not contain duplicate subsets. You may return the solution in any order. And I actually might, what's it called? So yesterday I was told about this problem solving method that I want to try out called, solving method, it's called umpire, and bite sized from my Discord server told me about it, and I kind of want to. I want to try it out. I haven't used umpire yet, so I don't even know what it is telling me to do. So understand the problem. Let me copy this. We're gonna try this approach together. My stream should be updated by now, so I should check that as well. So give me 1 sec. I'll fix my posture. Oh, there it is. Bet. So, oh, I gotta check if my audio's working, huh? But pretty much. Oh, hell yeah, it's working. This question is called subsets. It's a medium level question. All right, so subsets, understand the problem. So I guess for understanding the problem, we know that I already know that is a backtracking problem. My biggest question is how to determine if a prompt is backtracking, because although NeetCode is great and I love NeetCode mainly because you can use Vim motions in here, which is fucking amazing. It does tell you, like, the tree that you find these things in. It tells you what type of approach you can do, which is bad for me because I kind of just abuse that. So I know it's backtracking, but I want to kind of reverse engineer that and be like, why do I know it's backtracking? And I'm guessing maybe it's because you're returning all possible configurations of something. And then maybe not backtracking specifically is good for that, but recursive, it's a good way to, it's a good hint at a recursive solution. And another thing is unique integers, so we're not handling duplicates at all. And this is important because it simplifies the algorithm a little bit. Couple days, I think 2 days ago, I did one where it wasn't unique integers, and that had another extra condition you had to do. Solution set must not contain duplicate subsets. So you, if you have 1, 2, you can't have 2, 1, right? Because those are duplicate subsets. And you may return the solution in any order, right? So it doesn't matter how you find it. And you also, looking at the input and output, we know that an empty array is also considered a subset of this, right? Which is why in this base case, the subsets is nothing and 7. All right, I guess that's good enough for understanding the problem. Next up is match the problem with the interviewer. What the fuck does that even mean? Okay, I'm skipping that. Plan your approach and solution. Okay, so when I first started trying this problem, I really didn't know what the fuck I was doing. I knew that it was a recursive solution, right? And I tried different things. I don't remember what I tried, but I was getting close, but it wasn't like exactly there. Let me see what I tried. No, it's not even, whatever. I'm not even gonna try it. I'm not even gonna look for it. But I tried different things, and I kind of gave up after like the 20-minute mark. And so after that, I watched the solution. And pretty much what NeetCode introduced me to and what I want to remember is, I forget what he calls it. I think it was like the choice tree. But pretty much in my own solution, I started. Oh yeah, I remember. I started with this array, and then through recursion, I built trees, branches from each index to try to find my different subsets. And then near the end, when I was giving up, I did think of a solution where you start from nothing and then you build up to a subset of at maximum this size, right? And so NeetCode's solution did something similar where you start off with an empty array, and it's called a choice tree or whatever, where you go from left to right in this array, and you ask, and you see, and you pretty much add this one, or you don't add this one, and then from there you can see how the things change, right? So if I go into my laser, where is the laser? Is this a laser? Nope. Is it called pointer? There was a laser I pulled out earlier, but I don't know how to get that shit now. Oh. What's that do? What's this do? I'm trying to get really good at Excalidraw because I feel like all the key bindings are very helpful. Whatever. I'll just use this. And pretty much, if we have our index here, that's big as fuck actually. There it goes here. If our index is here, we're looking at 1. We start with an empty array, and then we can pretty much say we're either adding 1 here, or we don't add it and it remains empty. And then from there, we can keep doing this, but with the other indexes. So at this recursive call, we have to move it because we want a different number. And then from there, we can be like, oh, we want to add 2 here. Jeez Louise. We want to add 2 here, right? I feel like I'm making this too complicated. Let me do this. Yep. Okay, cool. I want to add 2 there, or not at all, so it stays 1. And over here, you do it with the empty as well. So then this will be, you add 2, or you don't add 2 at all, and it stays empty. And then we can move our index once again to 3, right? And then once we are at 3, how do I get that pen? It's, what's that button? X? So E, X, E, X, E, X. Okay, bet. Once we're at 3, we're at the end of this array. So that's a good marker that if our index is at the length of our nums, then we can say that we can end our recursive calling. And at 3, we either add it or we don't add it. So 1, 2, 3 when we add it, or it just stays at 1, 2. Here we add 3, so it's 1, 3, or nothing at all. And these are all subarrays. I'm just kind of lazy to draw the brackets. 2 will have 3, and then nothing at all. Or here we'll just have 3. Oh, sorry, 2. And here we'll just have 3 or nothing at all. And so in the end of this, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 possible subarrays that we appended, which matches up correctly to this output. And if you redo it again, just to check this input, you're going to have 2, right? And then you can derive this to be like, oh, so there's 2 recursive calls per one function. So in my data structures class, it's a good rule of thumb to say that it's the amount of recursive calls to the power of n for its worst case time complexity. And so for this one, it would be 2 of n, where n is the length of this array. And so that actually matches up because here we have a len of 3, so 2 to the power of 3 is going to give us 8. Here we have a len of 1, so 2 to the power of 1 is going to give us 2, which is the 2 things, right? So that is the solution drawn out. Let's see if I can code it in a way that makes sense, right? So in subsets, we know that we have to have a recursive function. I'm gonna call it def first search. I should make this bigger. All right. Well, I know we call it def first search. It has to take in some parameters, right? It's gonna have to have some base case that breaks out of our recursive call, and then our recursive calls. And we know that we will have 2 recursive calls because we're branching out twice in our drawing, right? So that's the basics of it. I know that I was keeping track of a integer here, so it probably is going to be used as a parameter that we can increment throughout our recursive calls, right? And then a pattern that we recognize is that at every level, so if I go to drawing here, at every level here, our index is looking at some other value. So here our index is going to be 0. Here the index was 1, and here the index was 2. So we know when we first call our def first search function, our index is going to start at 0, right? And so at every level we go down, it gets incremented by 1. So it's safe to say we increment it by 1 here. Our base case I mentioned earlier that it's a good idea to say that once our index gets to the length of nums, it's a good idea to break out. And so we can say if index equals the length of nums, we can then break, return. So that's what cancels our continuous recursive calls. And also we need a way to store our answers, right? And our subarrays. So that would also probably be good in our parameter. So we have subarray here. And how will the subarrays look during the recursive calls? Our subarray in our base case is going to be a 0, right? And so here we can make it an empty array to match up with what we had when we started. And then we notice that in one recursive call, we are adding something, and one we're not adding anything. It stays the same, right? It stays the same. We're adding something here. And so we can say that in our subarray that we're tracking, we can keep, I don't need to do this. We can keep our subarray the same for this. So this parameter up here will just get moved down to here, right? It just passes through, nothing changes to it. In our first call, but it doesn't have to be the first call because the order of the solutions doesn't matter. But for the sake of keeping